Here we got screencast 6, part A. The question states two people pushed in opposite directions on a crate sitting on a frictionless surface. Crate is at rest at point A and ends up at rest at point B. Describe how much work is being done by each person. So I've got the finish. This is the finished position. The kinetic friction is 0. Starting position, kinetic energy or kinetic initial is 0. So the work kinetic theorem states if work equals the kinetic final minus kinetic initial, those two values are 0, so work would equal 0. So the key words within the problem are starting at rest and ending at rest. Those give your values for 0 for your kinetic final and kinetic energy initial. There's a second part to the screencast, which is broke up into two questions. Part A states or asks, if you climb to a height h, which is right here, how much work is being done on you by gravity? So you're starting at 0, you're ending up at h, a height of h. So we just have work equals mgh final minus mgh initial, where we have mass times the negative gravitational field constant, height final minus the minus 0, because this would go to 0 because you're starting out at 0 as your height. So the total work done on you by gravity is negative mgh f sub f. Negative mass times the gravitational field constant times your height at final. Part B asks how much work is being done on you by the rope itself, and it gave a little hint. So basically from the hint I got, if your hands aren't moving, no work is being done. So I broke this up into two different equations to describe that, where my kinetic energy final minus my kinetic energy initial are both 0 values, which work will give you 0 because the hands aren't moving, so there's no energy. Or I did the mgh final minus mgh initial, and if your hands aren't moving, you're starting at 0 and ending at 0, so their overall would have to be 0. So there's my diagram, and there's my solutions to the screencasts.